In 4.1, we learned how to solve a quadratic equation by factoring and using the zero product property. In 4.2, we're going to learn another way to solve quadratic equations. This way is called completing the squares. So, in order to complete the square, it's based on this concept. If all your variable terms, so all the terms that have an x variable or a y variable or whatever variable you're using, if all those terms are on one side of the equation and they form what's called a perfect square, so remember perfect square, you can take the square root of it, right? So if all the variables are on one side and they form a perfect square, then in order to solve for x, all you have to do is take the square root of each side. Example 1 is an example of fitting this description. So all of my variable terms are on one side, right? X squared is by itself, and x squared is a perfect square. So I can square root both sides. The square root of x squared is x. But remember, when I take a square root, I need to go ahead and take the plus or minus, okay, because that's the definition of square root. So plus or minus the square root of 16, and the square root of 16 is 4. So x is equal to plus or minus 4. So that means that either x is 4 or x is negative 4. Okay, so let's go ahead and do a little bit more difficult one. That was kind of a simple perfect square. In example 2, it's going to get a little bit more complicated. Example 2 looks like this. X plus 3 squared equals 5. So I have something that's being squared. So I'm going to go ahead and take the square root of both sides. So when I take the square root of both sides, the square root and the square cancel, leaving me x plus 3 on my left-hand side and plus or minus the square root of 5 on the other side. Okay, so now I need to subtract 3 from both sides. So now I get x is equal to negative 3 plus or minus the square root of 5. And that becomes my final answer. So I don't have to actually figure out what the square root of 5 is since it's not a perfect square. I'm just going to leave it just like that. Okay, so this x plus 3 squared, this can actually be rewritten, right? Because isn't x plus 3 squared, let's just take a second and think about this. X plus 3 squared is the same as saying x plus 3 times x plus 3, which if you use your box method is going to be x squared plus 6x plus 9. So if I had x squared plus 6x plus 9 is equal to 5, I could rewrite this as x plus 3 squared and then use my perfect square technique to solve for it. So sometimes we are not given a perfect square. Sometimes we're given a quadratic equation that's not in a perfect square. So we had to have a perfect square trinomial in order to use this method that we've been using where we square root both sides. So we have to rewrite our trinomial as a perfect square. Doing that it's a process called completing the square. So sometimes we're giving a trinomial, and if it doesn't become a perfect square, we're going to have to make it become a perfect square. And we're going to do that in a process called completing the square. So the first thing we want to do is, if we have in our general equation, we want to change it from the standard form. So you're going to change from x squared plus bx plus c equals 0. And we're going to isolate our variable terms, because remember we want only our variable terms. So we're going to subtract c from both sides. Okay? And then once we do that, we're going to take half of b remember, b is the coefficient in front of x. And then we're going to square that. So square half of b. Okay, and then add the 1/2 of b squared to both sides. Okay, and that's going to result in a perfect square. And then once we have a perfect square, we can solve it just like we solved examples 1 and example 2. So let's see a problem like that. Let's go ahead and look at example 3, where we have x squared plus 8x minus 9 equals 0. So step 1, we want to take our c term and move it to the other side. So we're going to add 9 to both sides. So now we have x squared plus 8x equals 9. Then we're going to take half of b and square it. So we're going to take 1/2 of 8. And then we're going to square that. So half of 8 is 4. And then 4 squared is 16. So we're going to take 16 and we're going to add that to both sides. So we have x squared plus 8x plus 16 equals 9 plus 16. So now we have a perfect square, a perfect trinomial, right? So we have a perfect square trinomial here. So this factors into the square root of 16 is 4. So we get x plus 4 squared. And then 9 plus 16 is 25. So now we can solve it just like we solved examples 1 and example 2. We'll square root both sides. So we get x plus 4 equals plus or minus the square root of 25. And the square root of 25 is 5. So x plus 4 is equal to plus or minus 5. And then we'll subtract 4 from both sides. So x is equal to -4 plus or minus 5. So if you have -4 plus 5, then that means x is going to be equal to 1. However, if you have -4 minus 5, that means you have x is equal to -9. So those are our two solutions. Okay, so that is completing the square. Okay, so if our leading coefficient of our polynomial is not 1, so in this one it was 1, right? That one, the leading coefficient was 1. If it's not 1, we have to factor the leading coefficient from the polynomial before we complete the square. So it makes it a little bit more complicated, but it's still doable. So we'll try an example like that. This is example 4. We have 3x squared plus 6x plus 2 equals 0. We'll start with removing our c. So we're going to subtract 2 from both sides. So then we have 3x squared plus 6x equals -2. So I need to factor out that 3 on the left-hand side. So then I'm if I factor out the 3, I'm left with x squared plus 2x. Because 3 times x squared is 3x squared. 3 times 2x is 6x. All right, so now when I complete my square, I'm still going to take half of b, which is 2, and then square it. So half of 2 is 1, and 1 squared is 1. So I need to add 1 to both sides. Okay, I need to add 1 to both sides. But when I add 1 to both sides, I need to remember I'm going to add a 1 here, so x squared plus 2x plus 1 equals -2. And I want to add 1, but I'm not just adding 1. This is actually 3 times 1. So I'm adding 3 to the right-hand side. I added 1 on the left-hand side, but I actually added 3 times 1 on the left-hand side. And 3 times 1 is 3. So that's how I got the 3 on the right-hand side. Okay, so now I'm ready to continue. This right here is a perfect square trinomial. So this becomes x plus 1 squared, because the square root of x squared is x and the square root of 1 is 1. And then -2 plus 3 is 1, right? And then I need to solve, okay? Before I can square root both sides, though, I need to divide by 3. So now I have x plus 1 squared is equal to 1/3. And then I'll square root both sides. And remember, when you square root, you get plus or minus. So I have x plus 1 equals plus or minus the square root of 1/3. Then I'll subtract 1 from both sides. So x is equal to -1 plus or minus the square root of 1/3. All right. I'm going to do one more example, and then we'll be done. Example 5. We have 3x squared minus 13x equals 10. So now we've already moved our c value over, so that's good. I do need to factor out a 3, right? So I need to factor out a 3. So remember, when you're factoring out a 3, you're really dividing both coefficients by 3, right? So 3 divided by 3, that leaves us with x squared. And then -13 by 3, that gives us some crazy decimal, which we don't like. So we're actually just going to leave that as 13/3. All right. So now I need to complete the square. So I need to take 1/2 times my b value, which is -13/3. And then I need to square it, all right? So that becomes -13/6 squared, which is 13/6 squared. First of all, it's going to become a positive. And so that's what I need to add to both sides. So here's 3x squared minus 13/3x. And then I'm adding 169/36. Okay? However, when I add it to the other side, Remember, I'm not just adding 169 over 36, I'm adding 3 times 169 over 36. So 3 times 169 over 36 is actually 169 over 12. Okay, so I'll keep going. This piece right here can be rewritten as a perfect square trinomial. So it becomes x, because the square root of x squared is x, minus, and then the square root of 169 over 36 is going to be 13 over 6. And then 10 can be rewritten as 120 over 12. So that way I can add 169 to it. So that becomes 289 over 12. And then we're going to divide both sides by 3. Since I'm already dealing with fractions, one way to think of it, instead of dividing both sides by 3, I'm multiplying both sides by 1/3. Right? So then I get x minus 13 over 6 squared equals 289 over 36. All right, so now that I have something that looks like I can square root both sides, remember we get plus or minus when we square root. So we get x minus 13 over 6 is equal to plus or minus the square root of 289 over 36. And it just so happens that the square root of 289 over 36 is an actual number. It's going to be 17 over 6. So x is equal to, we're going to add 13 over 6 to both sides. So 13 over 6 plus or minus 17 over 6. So if you do 13 plus 17, you're going to end up with 30 over 6. Which is 5. But if you do 13 minus 17, you're going to get x is equal to negative 4 over 6, which is negative 2/3. So those are our two solutions. All right, go ahead and try some on your own.